Unit 6, Lesson 5, Antiderivatives and Indefinite Integrals, Basic Rules and Notation. A function, capital F of x, is an antiderivative of a function, lowercase f of x, if capital F prime of x equals lowercase f of x, for all x in the domain of lowercase f. The process of finding an antiderivative is antidifferentiation. The family of all antiderivatives of a function, lowercase f of x, is the indefinite integral of f with respect to x and is denoted by the integral sign f of x dx. This is exactly what I had given you in the last video. I said it was an indefinite integral. Right? I said, okay, it's an indefinite integral if it doesn't have something from a to b. And I said the answer was going to be a function. So it's not only one function, it's a family of functions. Okay, and I'll show you why we say that in just a second. So if capital F is any function such that its derivative is that little f of x, then the integral of that derivative f of x dx is that capital F of x plus some constant c. That is called the general solution, and c is called the constant of integration, and it's just some arbitrary constant. So looking at this graph right here, before we start example number 1, this is all kinds of vertical translations of f of x equals x cubed. I don't know if you think it looks like x cubed, like the x cubed function, like of course this one right here is just x cubed because it goes through the y-axis at 0. So it wouldn't have a plus 0 there. But the one that is up, this one right here is going to be x cubed plus 3. This one's going to be x cubed plus 5. This one's going to be x cubed, it looks like it's about at minus 3. This one is x cubed minus 5, okay? But if we take the derivative of all of these, like if I just kept saying, okay, x cubed plus 3, and I said f of x equals x cubed plus 5, look what happens when we take the derivative of every single one of these. 3x squared. This one, 3x squared. This one, 3x squared. Because the derivative of the constant is 0. So if I'm asking you to integrate 3x squared dx, I'm asking you to think, if this is your derivative, what would your original function be? Your original function is the answer to that. So there's going to be a way to do it. If you have x to the n and you're integrating with respect to x, you're going to take x to the n plus 1, and instead of multiplying, we are dividing by n plus 1. Okay, that's our little rule. And then that would be plus some constant, right? So we've got our 3, and you can bring your 3 out front if you want to, and say that you're just looking at the integral of x squared dx, and then you can use my little rule there. Take x to the 2 plus 1, and then divide by 2 plus 1, and then plus some constant. And do you see how that's going to cancel those 3's, because 2 plus 1 is 3? So this is going to be 3x to the third over 3 plus c. The 3's will cancel. So this is just x to the third plus some constant. So we don't know, was it this one? Was it that one? Was it that one? We don't know. So we say the answer is x cubed plus some constant. So now if they gave me a point, I'd be able to substitute that in because, of course, this gave me, y or capital F, whatever you want to call it. They were calling it capital F. They were calling this little f, right? They were calling this right here little f, and so they would be calling your answer to your integral. That's what they're calling big F, because they're saying that the answer then would have been big F of x plus c. But the reason why they put that c on there is because we don't know which one it is. That's why we call it a family of functions. Okay, so when you get the answer of x cubed plus c, that's considered a family of functions because we don't know what the c is. Okay, so now let's look at example number 1. We know that if a function f has an antiderivative, capital F of x, then there is a family of functions which share the same antiderivatives, and they will differ only by a constant c. State 3 functions, f1, f2, f3, whose derivatives are f of x equals 3x squared. So, it could be anything. You could say, well, it has to be x cubed plus something. I could say f sub 1 equals x cubed plus 2. I could say f sub 2 equals x cubed minus 10. I could say f sub 3 equals x cubed plus, 100. All of those have the same derivative. Okay, and you could have picked different ones, but they should have x cubed and then some constant. Explain the meaning of plus c on your functions above. So the plus c for f sub 1 of mine is plus 2. This one is minus 10. This one is plus 11. But they are telling you the vertical shift of your x cubed. So I'm going to say the graph of y equals x cubed is translated, and I'm going to put the plus c up or minus c down. Okay, we don't know what that plus c is. It could be positive 100, could be negative 10, could be 1/3, right? Up 1/3. It doesn't have to be an integer. It could be a fraction. It could be a square root. It could be, anything. Some constant, though. It has to be a real number. Okay, example number 2. Applying basic rules. Given each derivative below, find the general antiderivative by guess and check. Okay, so I kind of showed you a little rule over here before they actually showed it to you, right? And you can use that because when they give you the derivative, you're thinking, okay, if that's my derivative, and I want to find out what my actual g of x is, I'm going to integrate that derivative to find g of x. So that tells me that, okay, this 2 was brought down, and then I decreased that by 1. Well, that must have been a 2 here, because I brought it down, and I decreased it by 1, right? So if you didn't bring it down and didn't decrease it by 1, or if you want to say, okay, I'm going to bring the 2 out in front, integral x dx, and say, okay, this is going to be 2x to the 1 plus 1 divided by 1 plus 1 plus c. You can see that your 2's are going to cancel, and this is just x squared plus c. And if you thought about it and you knew that the derivative was 2x, you're probably taken that so many times, you're like, oh, that was x squared. The next one is t squared. So again, if I wanted to find f of t and I had the derivative, then I would integrate my t squared. Okay? So now think of it as t to the 2 plus 1 divided by 2 plus 1 plus c. And think about if you brought the 3 down, it would cancel with that, and then you'd reduce that by 1 and be t squared. Okay, so if I want my y, I'm going to integrate my 1 over x squared dx. Now for this one, I would bring this up as x to the negative 2 and use my same thought process, x to the negative 2 plus 1 divided by negative 2 plus 1 plus c, which is going to give us basically negative, well, I'm simplifying it, and I probably shouldn't because I don't want to mess you guys up. So let me just take a couple steps here. X to the negative 1 over negative 1 plus c, negative 1 over x plus c is what that would simplify to. Okay? Now, what can I take the derivative of that would give me cosine? You should be thinking sine. So that's going to be f of theta equals sine theta plus c. Because if I take the derivative of sine theta, I get cosine theta. Okay, so this one, if I want to figure this one out, you're going to do the same thing. You've got your integral of 2/3 x to the 3/4 dx. And you can bring your 2/3 out front, integral x to the 3/4 dx. And then you've got your 2/3 x to the 3/4 plus 4/4. And then you're dividing by whatever that is, 3/4 plus 4/4. So that's 7/4, right? Well, if I'm dividing by 7/4, that's the same as multiplication by 4/7. Oops, I put equals. Sorry. I don't know why I put equals there. I wanted to put x to the 7/4. And so this would be 8 over 21 x to the 7/4 plus c. I guess I should have put my plus c in there a couple of times. But that one is going to be your antiderivative. All right, and the last one is f, okay? So if I wanted to find f of x, I would take the integral of e to the x dx. And I know that if I take the derivative of e to the x, I get e to the x. So this one's just going to be e to the x plus c. So that one was our answer for D. I was trying to see, did I circle? Here's C. I circled all of them. So those are just just the practice of finding your antiderivative. So the expression, the integral f of x dx, is read as the antiderivative of f with respect to x. So the differential dx serves to identify x as the variable of integration. The term indefinite integral is a synonym for antiderivative. Notation for antiderivatives: dy dx equals f of x, and dy equals f of x dx. So think of it as you're multiplying by dx on both sides, and the dx cancels on the left-hand side, and you get it here on the right. This is actually called a differential equation, okay? And it's like a small change in y and a small change in x. That's what your dy is and your dx is. A small change in y and a small change in x. So a general antiderivative is denoted by y equals the antiderivative of f with respect to x is equal to capital F of x plus c. So let's just make sure that we know our vocabulary. This dx is telling me my variable of integration. This f of x is called my integrand. C is my constant of integration. And this capital F of x is my antiderivative. The integrand is basically your derivative, right? I'll put that in parentheses because that's what you want to think of. If this is my derivative, what was my original function? And your original function is your antiderivative, okay? So example number 3, when integrating, think before you work. Practice will help you discover many tricks and techniques that make the integration rules fit your problems. Okay. So, here we go. Trick number 1, rewrite. So when I see a plus sign in between like that, I think of splitting this up into 2 separate integrals. And then I think, okay, well, I can bring my 5 out in front because I know the derivative of e to the t is e to the t. And this one, I don't know what I would do with that. How else could I write 1 over cosine squared t? Hopefully, and something where you would know that is the derivative of something. Well, hopefully you thought of, what about secant squared t? And I know that if I took the derivative of tangent t, I would get secant squared t. So it's also good if you know that this is some derivative, right? If you know that that is a derivative of something, then you are happy because you're like, oh, I can get this. So now this is going to be 5e to the t plus tangent t plus c. Okay. So trick number 2, multiply or distribute. So I don't know how to find that integral yet. So how about if we just multiply this out? So 3x times 3x is 9x squared. And then you're going to have a negative 3x and another negative 3x, which gives you that negative 6x. And then that positive 1 dx. So that is what you're taking the integral of. And so you could split these up to make it easier if you wanted to. Maybe since you're first starting out, you'd bring the 9 out front times the integral of x squared dx minus bring the 6 out front, integral x dx, plus this is just going to be integral dx because it's just a 1. But think about what could you take the derivative of that would just give you 1? Wouldn't it just be x? So when we get to that one, you'll be able to solve that. Now, how would I integrate x squared? Wouldn't it be x to the 2 plus 1 divided by 2 plus 1? And see, when I have that 9 there, that's going to simplify. And then minus 6, this is going to be x to the 1 plus 1 divided by 1 plus 1. And so that's going to simplify. And then we said if we have a derivative that's just positive 1, that would have just been positive x. So now I want to simplify that to 3x cubed minus 3x squared plus x plus c. Okay, trick number 3, separate fractions. So if I have a monomial in the denominator, I can think of every single one of these, and I'm going to separate everything out. Every single one of these divided by my denominator there, okay? And so this is going to simplify to the integral, and this is going to be 1 over x cubed, but I'm going to have to bring that up as x to the negative 3. So I might as well just do it now. I'm going to bring that 4 out, and this is going to be 1 over x to the 4th, but I'm going to bring it up as x to the negative 4th so that I can use my little rule that I have. I'm going to bring the 5 out, and this is going to be x to the negative 5th. Don't forget your dx when you're doing that, because you have to have your dx there or that's going to be incorrect. Okay, so this is x to the negative 3 plus 1, which is x to the negative 2 divided by negative 2. And then plus, I've got my 4. This is going to be x to the negative 4 plus 1, so x to the negative 3 divided by negative 3. Plus, I've got my 5 here, x to the negative 5 plus 1, so x to the negative 4 divided by negative 4. And then plus c. And of course, we want to simplify this and at the same time make it so that we have no negative exponents. So this is going to be negative 1 over 2x squared. This is going to be minus 4 over 3x cubed minus 5 over 4x to the 4th plus c. Okay, you had to be real careful there because you wanted to bring the negative exponent down, but you wanted to leave that 5 in the numerator, leave that 4 in the denominator, but bring that negative out. You know, so bring that x to the negative 3 down, but leave the 4 in the numerator, the 3 in the denominator, bring that negative out front. So you had to be careful on that one. Trick number 4, multiply options. Multiple options. That means we're gonna have to multiply this out and then divide it by the square root of x. So this one's going to be a little bit of work. So if I multiply this out, I get x squared, I get a negative 3x and another negative 3x, giving me a negative 6x and a positive 9 divided by the square root of x dx. Okay, so that was my first step. Now, since I have a monomial in the denominator, I'm going to break these up. This is going to be x to the 1/2, right, that I'm dividing by, and then minus 6 integral x over x to the 1/2 dx plus 9 integral I'm just going to make that x to the negative 1/2 because I would have to bring that up anyway. So for this first integral, this is x to the 4/2, right? Because 2 is the same thing as 4/2. And so 4/2 minus 1/2 is x to the 3/2. That's what that simplifies to. This is x to the 2/2 divided by x to the 1/2 is going to give you x to the 1/2. And then this one, we're just going to leave it the same on that step. Now you're going to integrate. X to the 3/2 plus 2/2 is going to be x to the 5/2. And when you divide by 5/2, it's the same thing as multiplying by 2/5. Minus 6. This is going to be x to the 1/2 plus 2/2. So that's x to the 3/2. And then division by 3/2 is the same thing as multiplication by 2/3. And then plus 9, we've got x to the negative 1/2 plus 2/2, which is x to the 1/2 divided by 1/2 is multiplication by 2. So this is going to be 2/5 x to the 5/2 minus, and then divide by 3, divide by 3. This is going to be 4 x to the 3/2. And then plus 18 x to the 1/2, or square root of x, plus c. I should put my plus c right there. Okay. So you're going to need a lot of practice with this. I'm probably going to give you some book problems also. All right, so match each function with this antiderivative where c is a constant. So you can see that if this is the function, this is like your derivative function, right? So if you wanted to take that antiderivative, which would be your original function, and say, okay, well, if I took the derivative of this, it'd be 3x squared. So I can already see, oh, wait, this one's 3x squared. So this one's going to be a. If I took the derivative of this, I'm going to get 6x squared. There's 2 of those. We got to keep going. Minus 8x. Okay, so that's this one. The other one had plus 6x. So right away, we see that this one is b. And then part C, we have, if we took the derivative there, we'd have 6x squared plus 6x. So you can see that that one's going to be your C. And this one's going to be 4x cubed. I mean, that didn't help you practicing how to take the antiderivative. If you wanted to practice it just to get some more practice in here, and you took your derivative function and integrated it, this would be 6x to the 2 plus 1 divided by 2 plus 1 plus 6x to the 1 plus 1 divided by 1 plus 1 minus 5x plus c. And so that simplifies to 2x cubed plus 3x squared minus 5x plus c. And then if you did the same thing with the second one, we've got 3x squared minus 12x plus 4 dx. So if I was integrating, this would be 3x to the 2 plus 1 divided by 2 plus 1 minus 12x to the 1 plus 1 divided by 1 plus 1 plus 4x plus c. So this would be x cubed minus 6x squared plus 4x plus c. And so you saw that that one was your first one. And then we could take the next one and integrate 4x cubed plus 6x squared minus 2x dx. And if you want to stop and try and do this one on your own and then just start that video back up again, that would be great. So 4x to the 3 plus 1 divided by 3 plus 1 plus 6x to the 2 plus 1 divided by 2 plus 1 minus 2x to the 1 plus 1 divided by 1 plus 1 plus c. So this is going to be x to the 4th plus 2x cubed minus x squared plus c. And then our last one, integral of 6x squared minus 8x minus 2 dx. Again, if you want to stop the video and solve this one on your own and then start it up again to see if you can do it, that'd be great. We've got 6x to the 2 plus 1 divided by 2 plus 1 minus 8x to the 1 plus 1 divided by 1 plus 1 minus 2x plus c. 2x cubed minus 4x squared minus 2x plus c. And so that one gave you your B. Okay, so we were correct there. I mean, you know, you can do it either way when they give you this, but why not just practice integrating since it's something that you're just learning? Now, what do we know is the derivative that gives us 1 over x? The derivative of what gives us 1 over x? Hoo. Look at all these. Let's just look at these derivatives. So if I wanted to take the derivative of ln 2x minus 6 plus some constant, okay? It's going to be 1 over 2x minus 6 and then times the derivative of 2x minus 6. That would be 2, and then the derivative of the constant is 0. Well, if I ended up with 2 over 2x minus 6, I'm going to factor a 2 out so I can cancel it. So this is going to leave me with 1 over x minus 3. So letter E goes right there because that was my derivative. So that means if I was integrating, that's what I would get, right? If I was integrating that. But actually, if I truly was integrating that, it would be ln absolute value of x minus 3 plus c. So you are going to have to take the derivative for these because that one, if you factored a 2 out, you could write it differently, right? If you factored a 2 out, it'd be like ln 2 times x minus 3. And then you could add them, and the ln 2 is a constant. Anyway, let's go ahead and look at F. Let's look at taking the derivative of ln 2x cubed minus 6 plus c. Okay, so this is going to be 1 over 2x cubed minus 6, and then times the derivative of 2x cubed minus 6, which would be 6x squared. So I have 6x squared over, I'm going to pull the 2 out. Divide by 2, I get 1. Divide by 2, I get 3. And this one's going to give me 3x squared over x cubed minus 3. So that's this one. And now let's go ahead and take the derivative of g, which is just ln of 2x plus c. And so this would be 1 over 2x times the derivative of 2x. And then the derivative of the constant is 0. So 2 over 2x, the 2's are going to cancel. There's your 1 over x. And so that one is g. And then that last one, just to show you that derivative, ln of 3x squared minus 6 plus c. So this is going to be 1 over 3x squared minus 6, and then times the derivative of that, which would be 6x. So this is going to be 6x over, I would factor a 3 out, and then divide by 3 would give me 2x over x squared minus 2. So over here, that was what you got, so that one is h. Okay, so match the antiderivative to its integral. So think about the, if you were taking the derivative of this, okay, because the antiderivative, you're trying to figure out, is this the derivative of that? Question mark, right? So if I was taking the derivative of negative cosine, well, the derivative of cosine is negative sine. So negative times negative is going to give me positive sine. So positive 6 sine of 3x plus 4, but then times the derivative of 3x plus 4. So that 6 times 3 is going to give me 18 sine of 3x plus 4. So here's our 18 sine of 3x plus 4. And if I was taking the derivative of this next one, the derivative of cosine is negative sine. So this is going to be negative 6 sine of 3x plus 1 times the derivative of 3x plus 1. So that's going to give you negative 18 sine of 3x plus 1. So negative 18 sine of 3x plus 1, that's j. If I was taking the derivative of this next one, derivative of sine is cosine. So this is 6 cosine of 3x plus 4 times the derivative of 3x plus 4, giving me 18 cosine of 3x plus 4. And there's your 18 cosine of 3x plus 4, m. And then if I was taking the derivative of this one, the derivative of sine is cosine, so this is negative 6 cosine of 3x plus 1 times the derivative of 3x plus 1, which is 3, giving me negative 18 cosine of 3x plus 1. Negative 18 cosine of 3x plus 1, this is my k. So now, here are your official integration rules. So integration is the inverse of differentiation. Differentiation is the inverse of integration. So they undo each other. So if I was taking the derivative of a constant, I would get 0. If I was integrating 0, I would get a constant. If I was taking the derivative of some constant k times x, it would just be k. If I was integrating k dx, it's kx plus c, because that is just the constant. So, oh, that must have been the constant times x, right, that I took the derivative of. Okay, so derivative of k times f of x, you can bring the k out front times f prime of x. If you're integrating k f of x dx, you can bring the k out front times the integral of f of x dx. If I'm taking the derivative of f of x plus or minus g of x, I can take the derivative of f of x plus or minus the derivative of g of x. If I'm integrating f of x plus g of x dx, then I can integrate f of x dx plus or minus the integration of g of x dx. The power rule, here it is that I showed you, this one over here, sorry. The derivative power rule, of course, is bring the n down times x to the n minus 1. The integral power rule is undoing that. It's x to the n plus 1, and then you're dividing by n plus 1, and of course plus c. The only time that doesn't work is if your n was negative 1, because if your n was negative 1, you would end up with this, which is this, which the answer is that, right? So the only time it doesn't work is if that's a negative 1, then you have a natural log function. Derivative of sine is cosine, so integral of cosine is sine x plus c. Derivative of cosine is negative sine. Integral of sine is negative cosine plus c. Derivative of tangent is secant squared x. The integral of secant squared x dx is tangent x plus c. Derivative of cosecant x is negative cosecant x cotangent x. If I was integrating cosecant x cotangent x, it would be negative cosecant x plus c. Derivative of secant x is secant x tangent x. If I was integrating secant x tangent x dx, it would be secant x plus c. The derivative of cotangent x is negative cosecant squared x. If I was integrating cosecant squared x dx, it would be negative cotangent x plus c. For the transcendental functions, derivative of e to the x is e to the x. Integral of e to the x dx is e to the x plus c. Derivative of a to the x is a to the x times the natural log of a. If I was integrating a to the x, it would be a to the x divided by the natural log of a plus c. Derivative of ln x is 1 over x for x greater than 0. If I was integrating 1 over x dx, it is going to be ln of the absolute value of x plus c. Don't forget your absolute value sign because we can't have a negative there. And the last thing that we're going to do is solve some differential equations. So in example 1, we explored a simple differential equation. dy dx equals 3x squared. So a differential equation is just a statement about the derivative of y with respect to x. We found a family of functions that had the same derivative. This antiderivative is the general solution. Now our goal will be to solve for y with a specific solution for the constant of integration plus c. So based on an initial condition that can be used to find c. Remember I told you that if I had a point, I could give you the exact one. That's what they're doing here. They're wanting us to integrate this derivative and get an answer that's going to be a family of functions. So this is going to be the integral of 2x dx minus the integral of 1 dx. I can bring my 2 in front. And this is just going to be, 1. So it's just going to be x plus c. But this one, this is going to be 2 times, this is going to be x to the 1 plus 1 divided by 1 plus 1. 2's are going to cancel. So this is x squared minus x plus c. That's my f of x, right? Because if this is f prime, I just found my f of x. But this is a family of functions because it has a c. Now, it tells me that my f of 2, now remember, this is like f of x, right, equals y, because, f of x equals y. So you're talking about when x is 2, my y is 5. So if I'm going to put a 2 in here and a 5 in here, because this is like my y value, I can solve for c. I'm running out of space here, guys, so I'm going to bring it up here. 4 minus 2 plus c equals 5. So 2 plus c equals 5. If I subtract 2 from both sides, My c is 3. So my specific solution is going to be x squared minus x plus 3. That's my specific solution. I did first find the solution that was the general solution. This is the one that you would use if they didn't give you a point. But since they gave us a point here, I was able to give this specific solution. Okay, because of that point. All right, so let's do the next one. They gave us the derivative. So we can say that our f of x is equal to the integral of 2 cosine x dx. And I can bring my 2 out front. And then I should be thinking, what can I take the derivative of that is cosine? And that would be sine plus c. So that's going to be 2 sine x plus c is my f of x. This is my general solution with the plus c. But I have this point. So negative 3 equals 2 times the sine of pi over 2 plus c. Well, the sine of pi over 2, I think you know it. Here's my pi over 2. This is the 0.01 cosine sine is 1. So I'm going to subtract 2 from both sides. My c is negative 5. So now my specific solution, f of x equals 2 sine x minus 5. So that is my specific solution to my differential equation. This thing keeps moving on me. Okay. So now, letter C. My f of x equals the integral x squared plus x minus 7 dx. So this is going to be x to the 2 plus 1 divided by 2 plus 1. X to the 1 plus 1 divided by 1 plus 1. And minus 7x plus c. That is my general solution. They gave me a point. So 1 is equal to 3 to the third over 3 plus 3 to the second over 2 minus 7 times 2. I'm sorry, 7 times 3. Sorry, I'm putting in 3 for x. And so 1 equals, so this is going to be 9 because one of my 3's goes away with one of those. That'd be 3 squared, that's 9. This one's going to be 9 halves minus 21 plus c. So 1 equals, our 9 minus 21 is going to be, what, negative 12 plus 9 halves plus c. So 1 equals negative 24 halves plus 9 halves plus c. Oh my gosh, I'm going to have to come up here. Sorry, guys. Way up here. 1 equals, this is going to be negative 15 halves plus c. And then I would add 15 halves to both sides. And this would be 2 halves. So my c is going to be 17 halves. And so my specific solution, I'll just put it down here. For this one, f of x equals x to the third over 3 plus x squared over 2 minus 7x plus 17/2. So you're just writing that function again with your c. Okay? So letter D. F of x is going to be the integral of 3x squared minus 4x plus 2 dx. And guys, I hope that you're kind of stopping the video and trying to, solve the integral on your own. I think that that is probably the way to go. So if you want to do that real quick and then come back to this. So this is going to be 3x to the 2 plus 1 divided by 2 plus 1 minus 4x to the 1 plus 1 divided by 1 plus 1 plus 2x plus c. So that's going to give you x cubed, because those 3's cancel, minus 2x squared plus 2x plus c. And they gave us this x is equal to -1 when y is -4. So -1 cubed minus 2 times -1 squared plus 2 times -1 plus c. -4 equals -1 minus 2 plus c. So 2, 4, 5, -5 plus c. We would add 5 to both sides. And our c is 1. So our specific solution is going to be x cubed minus 2x squared plus 2x plus 1. That's your specific solution. Okay. Letter E. G of t is the integral of t to the 1/2 dt. So I just wrote it as t to the 1/2 because I knew I wanted to use my rule of taking t to the 1/2 plus 2/2 and then dividing by 1/2 plus 2/2 plus c. So this is t to the 3/2, and then division by 3/2 is the same thing as multiplication by 2/3 plus c. So that's my general solution for g of t. And they gave us that g of 9 is 6. And so 6 equals 2/3, and then this would be the square root of 9 to the 3rd power plus c. So 6 equals, this is going to be 2/3 times 3 to the 3rd plus c. 6 equals 2/3 times 27 plus c. Divide by 3, I get 1. Divide by 3, I get 9. 6 equals 18 plus c. So if I subtract 18, I'm left with -12. And so my specific solution, g of t, is equal to 2/3 t to the 3/2 minus 12. Okay. And the last one. So our f of theta is the integral of sine theta d theta. So f of theta is, now, what can I take the derivative of that will give me positive sine? That should be negative cosine plus c. So that's your general solution. But then they gave us this point, so we're going to put that, oops, sorry about that. We're going to put that y value of 2 in. We're going to put the theta value of 0 in. And we all know that the cosine of 0 is 1, but since there's a negative in front of it, that becomes -1, so I'm going to add 1 to both sides. My c is 3. So now for my specific solution, f of theta is equal to negative cosine theta plus 3. Okay. So you have your homework for lesson 6.5, and